Hello everybody, welcome back to Virtual School Physics is Fun. Wan Liao is going to continue with application of refraction of light. So lenses will refract light, and there are two types of lenses. There is convex lens and concave lens. A convex lens is a converging lens. All the lights that are parallel will converge, will focus onto one point, which is called focal point. As compared to concave lens, it is a diverging lens. All parallel light rays will be refracted, diverging from a point called focal point. Okay, so let's look at some important terms of lenses. First and foremost, a line that passes through the lens, this is called principal axis. Now, it's an axis that cuts the lens into two halves horizontally. It's a principal axis. Compared to another axis that cuts the lens vertically into two halves, this is called optical axis. And this is the center, optical center of the lens, O. All parallel light rays will be refracted and converge towards a point on the principal axis called focal point, F. The distance between O, which is optical center, and focal point is called focal length. We use capital letter to represent the points and small letter to represent length. Okay, let's study the three rays rule of convex lens. Okay, now if the incident ray is a ray that is parallel to the principal axis, I call it ray P. P stands for parallel. Okay, so ray P will be refracted by the convex mirror towards F, the focal point. Okay, so incident ray is ray P. The refracted ray passes through F. As compared to if an incident ray passes through F, so I name it as ray F. Okay, incident ray passes through F, it will be refracted parallelly, parallel to the principal axis. So you can see ray P and ray F, they are actually opposite to one another. Okay, because here incident ray is parallel, here the refracted ray is parallel. Yeah, ray P, the refracted ray passes through F. For ray F, the incident ray passes through F. So they are opposite, right? Okay, the third ray, I name it as ray O, where O is the optical center. So ray O passes through optical center O, so it will be refracted straight. It will not bend, it will just go straight through the lens. Okay, so this is a three rays rule for convex lens. As for concave lens, we will learn in another video. Now let's reinforce on convex lens. Today's video, we are going to concentrate on convex lens. Yeah? So ray P converge towards F. Ray O passes through optical center O and it goes straight through. And ray F, it will be refracted parallelly. Alright, so where is the image of a convex lens? As you can see, the image is here. And so this image is formed at the intersection of refracted ray. You see, the image is formed at the intersection of these three refracted rays. Right, same as mirror, we know that image is formed at the intersection of refracted ray. for lens. For mirror, it will be at the intersection of reflected rays. Now let's study the characteristics of image of convex lens. Okay. Now, if the object is placed far away from the lens, let's say the object is at more than 2f. Okay, this is f. Remember, this is focal length f, and double the focal length, so we name it as 2f. So if the object is placed more than 2f from the convex lens, okay, so u is the object distance. That means it's the distance between object and the lens. Okay, so u more than 2f, so we draw the rays so that we can determine the image. We can draw the location of the image. So this is ray. What ray is this? Can you remember? This is ray P, right? Parallel to the principal axis. So it will be refracted towards F. And what about this ray? What ray is this? Of course, this is ray O. Okay, so ray O passes straight through. So the two refracted rays intersect here. Therefore, the image is formed here. As you can see, the image is diminished. It is inverted, right? As compared to the object, it is inverted. And if we put a piece of paper here, a screen here, we can see the image is formed on the screen. So this type of image is called a real image. All right, so the image of this convex lens, if u is more than 2f, is real, inverted, and diminished. So if the object is placed more than 2f, it is similar to the u is infinity, right? So u is more than 2f means it is taken as it comes from infinity. Okay, because if it is from infinity, the image will have the same characteristics. Now, the second case, if we bring the object nearer to the mirror and place it at 2f, so the object distance is 2f. Same thing, we draw ray P, okay, refracted towards f, and we draw ray O. There you see, the image is formed on the intersection of the two refracted rays. And if we put a piece of paper here, we can see the image. What is the characteristic of the image? So it is real because it's formed on the screen. It is inverted, as you can see, upside down. And it is same size as the object. Look, same size as the object. As compared to just now, the image is smaller, diminished. The third case, we bring the object nearer, further, nearer some more to the lens, and we place it between f and 2f. U is more than f, less than 2f. Ray P converge to f, ray O, right? So the two refracted rays intersect here, so the image is formed here. So again, the image is real, inverted, but now it is magnified. It is bigger than the object. The size of the image is bigger than the object, so we call it magnified image. All right, the fourth case, the object is placed at f. So u equals to the focal length. U equals to focal length. Ray P, ray O. Oh, you see here, the two refracted rays, do they intersect? No, the refracted rays are parallel. They are parallel. So, where is the image? We say that image is formed at the intersection of the refracted rays, but the refracted rays parallel. So parallel rays only intersect at infinity. Therefore, image is formed at infinity. So this type of image, can we put a paper or a screen there so that we can see the image? No, it is at infinity. All right, so this type of image is called a virtual image. So this image is not formed on the screen. It's a virtual image, and it is upright and it is magnified. Totally different from the previous cases. Okay, case number 5. We bring the object nearer to the lens. We place it at less than f. Okay, ray P, ray O. So these two refracted rays, you see, they are diverging. They are going to be further and further away from each other. So how do we draw the intersection of the rays? So if we were to trace backwards, and we see that they intersect here at the same side as the object. So because this is not a real ray, so we trace back, so we use dotted line. So you see the image is formed on the same side as the object. So if we put a piece of paper here, we can't see the image. Yeah, the image is not formed on the paper, but we can see the image. Okay, we can see the image, but not on a piece of paper, not on the screen. So this type of image is called virtual image. And you can see it is upright and it is bigger than the object. It is magnified. So at this position, when U is more than F, this lens behaves like a magnifying lens or magnifying glass. Right? So if you use a magnifying glass, you have to put the object near to the lens. Then the image will be magnified. All right, so we have 5 cases here. Let's summarize. So case number 1, U is equals to infinity or U more than 2F. So you can see the image is real, inverted, diminished. Case number 2, U equals to 2F. We put the object at 2F. And the image is real, inverted, same size. Case number 3, U is between F and 2F. The object and the image compare. The image is real, inverted, again, but is magnified. So we can summarize by saying that if object is more than 2F, equals to 2F, or between F and 2F, the image is real, inverted. Yeah, these first 3 cases, the image is real, inverted, but the size of the image becomes bigger and bigger, right? As we bring the object nearer to the lens, the image size becomes from diminished to same size to magnified. So we can conclude by saying that as the object gets nearer to the lens, the size of the image increases. Okay, case number 4, U is at F. Image is formed at infinity. And case number 5, U less than F. Now, object is very near to the lens. Image is virtual, upright, magnified. And it is a magnifying lens. It acts as a magnifying glass. All right, so case number 4 and case number 5, both of these have the same characteristics. The image characteristics are the same. That is virtual, upright, totally opposite compared to just now. Just now, that one was real. So now it is virtual. So instead of real, inverted, it is now virtual and upright. Total opposite to previous 3 cases. And of course, it is magnified because we say as the object gets nearer to the lens, the size of the image becomes bigger. All right, so this is all about convex lens. So we can say that the image of the convex lens depends on the object distance. Okay, the characteristics of the image of convex lens depends on the position where the object is. It depends on the object distance. So I summarize it into 5 cases. This 1, 2, 3, 4, and 5. Okay. All right. So that's all for convex lens. We will continue in another video with concave lens. All right. Thank you. Goodbye.